So the Pythagoras relationship is a squared plus b squared, or the two shorter sides of a right angle triangle, and again, to make sure it has to be a right angle triangle, a squared plus b squared, those two squares add up to the big diagonal square of c squared. So you'll be expected to be able to find the unknown square area. So in this case, we've been given the two smaller squares, 30 centimeters squared and 50 centimeters squared. And what we want is we want to find the area from this side. So this square is going to be 30 plus 50, and we're going to get 80 centimeters squared. So this is a Pythagorean relationship. It allows us to find square areas. For this next problem, we have the big square, the diagonal square is 120 centimeters squared. The small square is 10 centimeters squared. The square at the bottom has to be the difference. So since the two smaller squares add up to the bigger square, we're going to take away from the bigger square. So we're going to take away 10 centimeters squared from the bigger square. And that gives us, for the bottom square, 110 square centimeters that make up that area. So we can, although the Pythagorean relationship allows us to find squares, because we know how to square and square root, we can find unknown side lengths. So to do this, what we're going to do is we're going to find some square areas. So we know that this square is going to give us 7 centimeters squared, which is 49 square centimeters. And we know that the square off of this edge is going to be a 6 centimeter square, or 36 centimeters squared. So we can draw a grid of 636. So I'm just going to actually do this real lightly. So we can do, I can actually draw the 36, since this is a perfect square, I can actually draw 36 squares in here. Same here, since this is a 7 square, we can actually draw 49 squares in here. Okay, so that gives us the total number of squares in there. And what we want is the square from this diagonal side. The square from this diagonal side will then allow us to find the side length of C. So this is, when I add those together, I'm going to end up with 85 squares. Now to find the side length of C, we're going to square root. So C is equal to the square root of 85 centimeters squared. And again, I need my calculator for this. So punch that into your calculator. And your calculator should give you a number 9.219, which I'm going to round to 9.22. And that looks about right. Okay, so this length here is about 9.22 centimeters. And again, I want you guys to make sure that you never do this. You don't add A plus B equals C, because 6 plus 7 does not equal that diagonal side length. For this one here, same thing. This time though, we're going to have to find the diagonal area first. So this square, the big square, is going to be 25 centimeters squared. This square off of this side is going to be 9 centimeters squared. The bottom square is not the sum. We don't add these, because the bottom square is going to has to be the difference. So it's going to be 25 squares minus 9 squares gives me 16 squares. So 16 plus 9 equals 25. So that's the right area. There's my Pythagorean relationship. Now I use that, knowing that x squared is equal to 16, we can say that x is equal to, well, I need to undo the square, so I undo it with a square root, and I get x is equal to 4 centimeters. So that side length is equal to 4 centimeters. And again, 3 plus 4 does not equal 5, so we never add a plus b. It's a squared plus b squared equals c squared. It's the areas that are related to each other.